Alright, so I think I'm recording here. Let's take a look. We've got a bouncing spring problem. The weight attached to the end of a long spring is bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. A stopwatch is started when the stopwatch reads zero point 0.3 seconds. Um, the weight first reaches a high point 60 centimeters above the floor. The next low point at 40 centimeters above the floor occurs at 1.8 seconds. Find a particular equation for the distance from the floor as a function of time. Alright, so the high point, our maximum, is 60 centimeters. Our low point, 40 centimeters. Add those together and divide by 2 and you got your center line. And the amplitude is 10. Alright, now at 0.3 seconds the weight first reaches a high point. So let's call this the high point at 0.3 seconds. The next low point occurs at 1.8 seconds on the stopwatch. Alright, so 1.8 minus 0.3 is 1.5. That's half of the period. That's the distance from a max to a min is half of the period. So the period is 3 seconds because 1.8 minus 0.3 is 1.5, and if I double that, I have 3 seconds. My amplitude is 10 centimeters. Let's see. My starting point, if I want to use the sine curve, then we can start, we want to start on the center line, so we could back up, but then that would be starting like at a negative time, and I'm not sure if they would necessarily want that. So we could go over to here and go for this one cycle from here to here. We could start here and just do a reflection, do a negative value across the x-axis. Let me see, does the problem, there's different parts to this that I didn't copy, and maybe it suggests how long in seconds until the weight is at the center line heading up for the first time. So heading up for the first time here, let's see, it's heading down. So this is the one that they want. Alright, so if I yeah, okay. A fourth of the period is 3/4 of a second, or 0.75 in decimal form. So this is no it's not. 1.05 and 2.55. So let's use this 2.55 seconds and 50 centimeters as our starting point. So the spring bouncing up and down is a function of time. The amplitude is 10. The period is 3. We're starting to the right, so that's subtraction, because it's kind of bizarre on the behavior in the domain. And then the center line is 50. So here is our equation. I hope that helps, and I'll talk to you later.